This is Disruptors Unleashed, a series that explores the disruptive technologies shaping our world. Previously, we looked at the intricacies and the environmental impact of the refurbishment industry with our trailblazers, Jonathan Dutton from Dassault Systèmes and Camille Richard from online e-commerce platform Backmarket. Jonathan joins us again to speak with Tim McAloon, a professor at the Technical University of Denmark. He shares with us his insights on the game-changing ways that disassembly is shaping a circular and sustainable future.
Hello and welcome to this conversation on the positive actions that research, education and industry are taking to achieve a sustainable economy. From resource depletion to pollution to consumer satisfaction, there are more than ever a need to decouple material usage from value creation. And today we'll explore the need to disassemble today's manufactured products to recover resources, how products can be designed from scratch to be disassembled, and how companies can reap the rewards of circular economy practices for long-term business viability. I'm Jonathan Dutton, the Sustainability Marketing Director at Dassault Systèmes, and my guest today is Tim McAloon. Tim McAloon is a professor at the Technical University of Denmark, and Tim works closely with Danish and international industry, creating new methods and models for a wide range of sustainability-related product development issues, such as circular economy, sustainable design, eco-innovation, and Tim works with industrial companies, which is his main research object, and his international network spans very broadly. So, hi, Tim.
Hi, Jonathan. Nice to see you.
Hi, and you. Great to be here with you. So, Tim, just a general question, a bit of an icebreaker. Over your career studying circular economy, what do you think has changed most over this period? Like methods or acceptation or behaviors? So what do you think's changed most?
Yeah, so my career in sustainability and sustainable design actually spans back from 1993, which is when I started my PhD. And way back then, we were talking about how to look at the end of life and to go from end of life over to design for. So we design for end of life, but also design for a more suitable life for products and systems. And you can say in the 90s, there was a lot of focus on developing methods and tools for sustainability, or for eco-design, as we called it then. And since the turn of the century or turn of the millennium, you could say, there's been an increasing focus on systems design and not just product design. And then an increasing understanding in industry for the need to really understand how to design for the whole life cycle of a product or a system. The whole issue of circular economy has really come over the last 5-7 years or so as a very, very important focus for understanding how do we see our resources that we use in our products and systems as being resources we need to take care of again and again and again. And how do we manage to bring as much value as possible out of those resources we put into our products and systems, instead of simply understanding or not understanding, but simply when we're finished with them, discarding them and allowing them to decay into materials again. So I think this circularity mindset has really anchored the understanding that value creation needs to be decoupled from resource consumption. And that is finally something that industry is really embracing very, very, very much, in fact.
Okay, great. I mean, that's extremely encouraging because it feels as if it's taken a long time, but I think we're well and truly on the right route to this decoupling, I think. So that's great. So just as an introduction to, as I mentioned in my introduction, we'll talk about disassembly. So we'll try and decouple a few things on in this conversation.
Yeah.
Because I think most of the the people who are watching today are interested as well is in how can they do some sort of, I wouldn't want to say baby steps, but steps which they can deploy straight away. So that's why I wanted to talk a little bit about disassembly, and how do you think companies can optimize sustainable material use in current and future product designs?
Yeah, so at any life cycle stage of a product, we have inputs and outputs. So the inputs being materials and energy, and the outputs being the intended product at that life cycle stage. But at the same time, we also have byproducts, which could be wastewater, emissions, and so forth. And the idea of thinking in terms of sustainable design and optimizing sustainable material use is to think of the inputs and the outputs. How do we optimize the difference between the inputs and the outputs, and at the same time reducing those byproducts? So to reduce both the inputs and the outputs, there's actually a number of design guidelines that one can actually adhere to or can follow. One could be to minimize material consumption in the design of the product. Another one could be minimize the energy consumption to make the product, but actually of the product as well. A third one could be to choose low impact resources, meaning resources which have a lower impact in their mining, but also in their machining and their production, and in general, in the general CO2 footprint that they create when we take them out of the earth crust and make them into components and finally products. A fourth one could be to look at optimizing the product lifetime in general. So if we can design a product that lasts much longer, then we're going to postpone the time period or the time that that product will actually reach its end of life. We could also look at extending the material lifespan. And this is particularly interesting for circular economy, because there we're looking at how do we circulate materials as frequently and as often as possible. And then finally, we could look at an area of facilitating disassembly of the product. So if and when a product should reach not just end of use, but end of life, how do we facilitate its successful disassembly so that we can separate the product into components and the components into materials and see which of those can be utilized again and again and again. So that's just some of the rules of thumb, and there were quite a few there, and there's more. But I think in terms of taking baby steps, those could be some of them. So looking at materials consumption minimization, energy consumption, low impact resources, the product lifetime optimization in general, extending the material lifespan, and then facilitating disassembly.
Okay, great. I mean, this reminds me of the quote that we use quite often, that 80% of all product-related environmental impacts are locked in during the product design phase. So obviously, it's a lot more complicated than that, and it's quite a general statement. But I think it does iterate the fact that we've got to start from the very, very early stages to rethink how we do things. So I'd like to go into that a bit more detail later. But I was just thinking that, what about the very early stage? Do we have enough materials actually in circulation today to keep our economies thriving, or do we still have to go out and mine more raw materials?
Yeah, that depends on how you look at it. So if you look at our population, we're almost 8 billion on the globe at the moment, and we're set to rise for another couple of billion before it is estimated that we may even out in our population. And populations like to have their goods and their services, and goods and services, they need materials and resources and products and so forth. So if we look at a straight one-to-one, and if we keep on going the way in which we've been going so far, then I guess we don't have enough materials at all. Then we could ask ourselves about sufficiency, of course. Do we have sufficient, or do some of us have too much? But let's leave that discussion to the side. If we look at a perspective of, if we were now to say we would not mine any more materials ever, and do we have enough? I guess the idea and the whole, you could say the goal of circular economy is to say that we close loops infinitely, that we say that all mines are closed from now onwards, and we can use the resources we have and that we've taken out of the Earth's crust. Currently, that is not possible because of the way in which we've designed and developed our products. they're simply not designed and developed to be able to recirculate, to be recirculated and to be reused and upgraded or remanufactured or refurbished or what have you. So that's the one problem, is the way in which our current products and systems are designed. But the other thing is that if we think about recirculating at a materials level, and only at a materials level, so let's say that we're finished with our telephone and it goes to be recycled, we dismantle it, we take it down to not just a component level, but a material level, and we regranulate the plastic, the aluminium, the glass, and so forth. Something happens there that we need to inject new virgin materials if we take our products back down to a materials level, because of the mechanical properties are often or almost always weakened each time we go from a material up to a component and a product level, and then back down to a component and a material level. So if we only think about design for disassembly for recycling at a materials level, then no, we will never have enough. If we lift our expectations up to a component level or even a product level and look at recirculation of products and components, then we're getting closer to the answer of yes, we should have almost enough of some types of materials and components in circulation to be able to help us to at least extend product lives by a factor 2, 3, or 4. So we have you could say we have the know-how and we have the possibilities to do it, but just now we're not at that state. And if we keep thinking about recirculation and recycling at a materials level, we will never have enough.
Okay, that's clear. So that there must be, do we actually have, do you think, any, you said we're not quite there yet, but surely there must be a few examples. I mean, do you have any examples today of products that have a well-managed end of life? Because a lot of our customers, for example, especially in the automotive industry, are having to deal with end-of-life regulations. So do you have any examples of materials that are actually recovered today or reused?
Yeah, so I think it's an important question, John. And first of all, let me challenge the idea of thinking about end of life, and to something I said a little bit earlier about extending life or finding optimal lifetime of products. And it really is important to challenge ourselves with the extremes when designing and developing products, because it would be wonderful to be able to design a product that we have no need to think about the end-of-life qualities because they just last forever. And I'm wondering whether you and I have ever seen a piece of designer furniture on a dump, on a recycling center. So like a famous Danish design furniture or a French design piece of furniture. And do we ever see the real classics on the rubbish dump? Probably never. And are they designed optimally for their life cycle? I guess so, because we've put so much effort into designing and developing these products in a way that makes them desirable objects. But I know that this is really the panacea and the goal that we would love to be able to reach. And it's not possible in many, many cases in many industries, and I know that. But still, we should try and think about how we might optimize the product longevity in order to postpone that period. But then back to the question you asked, and you just gave me some time to think about some examples. If we're thinking from a product and then a parts and then finally the materials level, what examples could I think of? Well, actually, in the world of office furniture manufacture, there's been a really healthy competition for quite some years now between different companies about designing products which are eco-efficient, meaning they're using as fewer materials as possible, but also eco-designs so that they could be disassembled, refurbished, upgraded, and so forth. And a really nice example I can think of is the Think chair from Steelcase. Steelcase is a large American office furniture manufacturer, and they made the Think chair. It's a chair called Think, an office chair, just about a decade and a half ago, actually. Beautifully designed for comfort and ergonomics, but also designed for disassembly so that it can be repaired and upgraded and so forth. So that's a nice example. If we look into a electronics product. There's a telephone called the Fairphone, which I guess a lot of people would have heard of. And the Fairphone is born circular. It is modular design. It's designed with, you could say, with redundancy built in. Redundancy meaning there's space for upgrades of the camera, there's space for upgrades of the chips and so forth. And it's designed so that you can swap in and out different components if they were to fail, but also if you would like to upgrade or maybe downgrade. If we stay in the electronics sphere, Apple actually is making a move over to looking at how do we actually valorize actually the materials level, but also a components level, the different components that go into their telephones, their tablets, their computers. And if you were to take your phone into an Apple store, they will inspect it for you and see what condition is it in. And depending on the condition it's in, will offer you a voucher for your next purchase, because they can see a value in the components and the materials. And when they take the components and the materials back, they have a robot, I think it's called Liam, the robot, which basically disassembles the telephone into the components because it's their specified metals, it's their specified glass, and it's their specified different components that they know exactly what the level of quality is. So they're actually making a business out of saving money, but also resources by encouraging us, the users, to bring our products back and giving us a small prize for that, and keeping the benefits for themselves, but also for the environment there. If we look at Philips, the Dutch company there that has many different products, and traditionally in the consumer products industry as well, but more and more in the healthcare industry is their main focus these days. They have a big focus on materials efficiency. If you just look at their packaging, you will almost not find any plastic in their packaging, and haven't done for over a decade now. It's cardboard and it's a mono material, making it easier to sort and to recycle at the end of life. But also in their products, they're looking to make the products more and more efficient and more eco-effective over their lives. And then if I can think of a final example, which is one from my home base here in Denmark, the high-end hi-fi equipment manufacturer and designer equipment manufacturer Bang & Olufsen has just launched a product called BioSound Level, which is actually the first actually born circular product from their company, and actually one of the first that I can think of in this part of the world, which is basically, again, it's a modular designed Bluetooth loudspeaker. Beautiful design. It has that timeless design that hopefully will mean it will never come onto the dump, as I mentioned before, designer products. But if we should upgrade our technology as a society from Wi-Fi through Bluetooth to something else, it has the modular design inside. The battery is replaceable. You could say that may not be a surprise, but over the last decade, we've gone away from that type of a design in many consumer electronics. So the battery is replaceable, upgradable. There is space for upgrade in there as well. So that's some, you could say, guiding styles of product designs that try and retain the value as high as possible. And if the product value can't be retained, then we'll see the component level. And otherwise, we go down to the materials level. I think that rule of thumb, product and component materials, is being applied in all of those examples, I think.
Excellent. Well, it's very encouraging to see that there are quite a few companies now that are tackling these issues and also producing really appealing products. And I hope we will be able to go back to these companies just a bit more detail. But in the meantime, I just wanted to finish around this topic of disassembly and just a more of a fun question. Do you know the difference? Is there a difference between dismantling and disassembly? We hear both these terminologies used a lot. Is there any difference for you?
In my dictionary, there's no difference. I said dismantling and disassembly is the same type of activity, but I think that it depends on what the intention of dismantling is. And I think there, again, if you take this hierarchy of products, components, and materials, then depending on where your final goal is with your dismantling and disassembly, you'll be more or less careful. So if we were just to get the metals out of our telephones, then we could just throw it into a crusher and shred the telephone into pieces and then recover the metals. There'd be a lot of waste there in other materials, but that's also a kind of dismantling. Maybe not quite. I think dismantling, disassembly implies a slightly more careful attention to detail, to be able to take components from each other, away from each other, to separate components is the word I was looking for. But I think whether you're going to design your recovery system to repurpose a product, you'll have one kind of dismantling or disassembly activity. If you're going to remanufacture for further use or future use, you'll have another strategy. If you're going to repair or maintain a product, then you need to have other types of dismantling and disassembly activities, upgrade the product, and so forth. So there's, I think, depending on what the intention is, you will be more or less careful in your dismantling and disassembling activities. But otherwise, I see no real difference between the two words.
Okay, great. So that leads nicely to the next question, which is, if you were to disassemble for recycling or for reuse, what sort of the strategies, what sort of advantages could we see out of those two things, from recycling and reuse? How would we disassemble for either one?
Yeah, and there is a difference. So if you were to disassemble for recycling, then what would be ideal to be able to disassemble for recycling would be if the parts within the product are alike, if they're as similar as possible to each other. Also the materials, as many materials which are alike as possible. But then also, if we're going to disassemble for recycling, it would be nice to be able to access the high value materials as soon as possible, so that we can get to, not just as soon as possible actually, but also so that we can actually get to them. If we seal high value materials in a way which would either make them not economically viable to get to because they've been put at the bottom of the product, but also if we were to spoil the mechanical properties of those materials because we would need to, break a weld or to use a welding machine to get into that material, then that would be a bad idea. So I think that for disassembly for recycling, it's about having parts which are as alike as possible, materials which are as alike as possible, and then having easy access to the high value materials. If we go to looking at disassembly for reuse, then there's a slightly different set of design strategies that we could go for. And that could be things, for example, like make sure that we are designing reversible joints. Quite often we get a paradox between design for assembly and manufacturing, which will give it really nice, easy snap-fit joints, and then we can manufacture and join components together as fast as possible on the production line. But if we're going to reuse or disassemble a product to be able to reuse it, we need to be able to have reversible joints. So maybe those snap fits that we did for design for assembly need to be thought about for design for assembly and disassembly. So reversible joints are important. I mentioned in a couple of the examples before about modular design. Modular design is a really nice way of thinking all the way from the start when we're designing our products. How do we separate the different components? Maybe because one component would fail more often than the other. Maybe because we would come to an upgrade situation. Maybe because the product should be interchangeable, or rather the component should be interchangeable across numerous products. So modular design is a nice way of thinking about disassembly for reuse. So thinking about it upfront, designing for disassembly for reuse. And then generally about designing an upgradable product, a product which generally can be upgraded so it doesn't become obsolescent purely because of the technology, that the rest of the product, I think we all can think of examples of products which were working and functioning perfectly just for the technology. One small part of the technology meant that we actually had to discard it. So thinking about upgradability. And then similar to that, design for maintenance. How can we design a product which is easy to get to maintain and to keep serviced? And then maybe also the more digital we become and the more connected our products and systems become over time, design for diagnosing or diagnostics, and that could be remote diagnostics, so that the product may have a health check saying this component might need to be changed, or we might need to do a service on the product to be able to keep the longevity. And that also plays in terms of design for reuse. I know a number of examples of companies which are actually making a living out of taking electronics back and diagnosing the health of the computer or tablet or telephone, replacing the components which need replacing, and then putting them back out onto the market and saving us tons upon tons of CO2 equivalents of resources and of manufacturing necessity by keeping products going for longer and keeping them in.
There's a company in France called Back Market, which refurbishes electronic goods such as laptops and tablets and telephones. And they're a platform which enables a whole host of different of individual or small companies to refurbish these different devices. And the whole idea is to give people this desire that the product could even be better when it's refurbished, and then when it's brand new, it could have more options.
Exactly. You have with electronics what is often called burn-in. So not burn-out, but burn-in problems,
Yep.
I've been told. And burn-in is often what we call the teething problems or the teenage problems that electronics may have in the first months or years. And on speaking to some of these refurbishment companies, they say that quite often the product you get as a refurbished product can be more reliable than a new product, because all those teething problems have been experienced by the first user. And then when the second user gets it, then the product is then settled into its life and its operation with the user. So I think there can also be some really nice advantages there as well.
Okay, great. So, but this sounds like there's a lot of things moving around. I'm just wondering if there are any standards and norms in place that can optimize disassembly, and particularly what are the values of these standards and norms for companies and consumers.
Yeah, so I think standards and norms is actually quite an interesting one. So as far as I'm aware, I'm not sure that there's too many standards for disassembly. There are of course standards for joint types and sizes, and there's a whole standards book for snap fits, for example.
Yeah.
But in terms of putting it in place for a design for disassembly perspective, to my knowledge, there's not a de facto industry standard out there. You could say that the other way around is to say, can we make some agreements at an industry level that this and this type of screw will be used, or this and this type of a joint or joining technique will be used for these and these types of components. But I think we're a long, long way away from reaching any standards there.
If we're a long way from there, are there any regulations that are local or global regulations that are triggering the launch of new products that can be disassembled, or products which can embrace, which can fit more into a circular economy? And how today are companies leveraging these different regulations?
Yeah, I mean, there's tons of regulations out there. There are companies which actually their whole raison d'etre is to follow standards and regulations, and on behalf of manufacturing companies and other companies to show what regulations are appearing in which part of the world and where they apply to the particular company in interest. And they're growing almost exponentially around the world. If we take the European lens on, which I know best, so we have standards or rather regulations on a materials level. So the REACH and the RoHS directives, which is looking at chemicals and hazardous substances. And those directives and those laws have a number of, you could say, triggers to launching sustainable products from a materials chemistry and a materials safety perspective. And if we go slightly broader out, we have the whole right to repair movement in the European Union, which I think is really interesting. So the right to repair comes in the wake of a couple of decades where the right to repair has not been in focus, and often I'm asked, is it really true that companies have been allowed to make products which are designed for the dump or are not repairable or do fail before we would expect them to do so? And in France, you're the country which is the furthest ahead on this whole right to repair regulation, and actually taking companies and the company directors to court if you can prove that a product has been designed for obsolescence on the one hand, but more and more we're looking over to how do we make sure that the user can repair their products, and that has very, very clear design implications.
Yeah, there's the repairability index now in France.
Exactly that, yeah. So I think this is a movement which is long overdue, but really great to see is there. Then if we look to directives such as the Eco-Design Directive, this is becoming more and more the Eco-Design Directive. It was misleading in the start because it started being called the Energy Using Products Directive, and then it was the Energy Related Products Directive, and then it became the Eco-Design Directive. So it was starting around products which had a battery or a cable or a power supply of any sort. And that's broadening out to all different types of products, particularly with products which have some form of a main energy use is one of their main contributors to CO2 equivalents, if we use that as a proxy in the usage phase. So the Eco-Design Directive is more and more guiding us and triggering sustainable design in companies there. If we look at the end of life, and particularly within, for example, electronics products, we have the so-called WEEE directive, Waste Electrical and Electronic Equipment Directive, which is basically, it applies at a country level, and currently there's a levy which needs to be paid, and then at a country level, we see voluntary schemes by the industry itself to see how can we use the resources that we're paying in that levy in a way in which it ensures responsible handling of products at their end of life. And of course, the best way to responsibly handle a product at the end of life is to not let it get to end of life. But that gets back to my point before. Slowly but surely, we see these different policy instruments working together. Two more I have in my mind in terms of regulations which are triggering. One is the emerging EU taxonomy for sustainable activity. And this is pinpointing a number of areas for certain industries to simply focus on in terms of making sure that they really design their products and systems to be within the law. And this is you could say it's an early flag for what will come in legislation later on. So looking at the EU taxonomy for sustainable activity is a really smart way for industries and industry sectors to see what will come in the future and how can we design our products now already to be able to fit within those frameworks.
Yeah, I believe that just on the EU taxonomy, I believe that companies now are having to declare in their annual report, the percentage of the products that they're producing which fits under the criteria of climate mitigation, for example, for this year.
Yeah, so we're starting with the reporting, and this is a classic instrument where you start to report what we have, and then slowly but surely we start to say, when we know what the size of the problem is, then, just reporting it in the first instance makes makes for a sharpened awareness. And then after that, the shareholders can see how much is being reported and push from that perspective. And then the other side, the other pull will come in terms of making sure that we go for increased improvements, increased efficiency in those areas. And I think the final, it's not a policy instrument, but it's a regulatory instrument, let's call it that, is the Science-Based Targets Initiative. And I can't help but name this one because I think that it's, from my perspective, it's one of the most promising ways of committing industries, or actually industries committing themselves to making really, really bold improvements or targets for improvements towards, in fact, the Paris Agreement, so the agreement to try and mitigate the amount of CO2 emissions or CO2 equivalent emissions we're producing. So the Science-Based Targets Initiative, some may have heard of it in terms of the scopes, the Scope 1, the Scope 2, and the Scope 3. Scope 1 is basically what is inside our company premises, our factory, our company vehicles, and so forth, making targets to reduce our CO2 footprint there. Scope 2 is the energy flows, as I was saying right at the beginning, the flows of utilities basically through our company. And the more a production facility we have, the more utilities we need in terms of heat and power and water and so forth. Scope 3 is everything else, both the upstream and the downstream of the value chain. All of the components we buy in, and all of the different materials we buy in, and all of what happens to them when we actually sell them and they're out in the market. And many companies are seeing that over 90% of their products embedded CO2 is in the Scope 3.
Yeah. Okay. So that's what's hidden under the iceberg. That's the big one.
Exactly that. And until this initiative, I've seen very little that has actually addressed this Scope 3, all of the 90%, and made it the responsibility of the company. Well, that's not fair to say made it the responsibility, because the companies are actually themselves volunteering into this initiative. It's called an initiative and not a regulation. And companies are making bold statements and going public with these statements about their goals. And this fits directly up to the Paris Agreement CO2 reduction goals. And I think this is a really nice regulatory instrument because it's voluntary. It's completely voluntary, and it's an initiative which isn't coming from the legislators. And I've spoken to many legislators in my time, and they all tell me that the best way of regulating is not to make legislation. Legislation is the last step. If we can manage to create a movement without having to legislate, then we're in the absolute best situation at all. Quite often people ask, is the market or is the legislator the main responsible? But I think it's always a dual activity, and the Science-Based Targets Initiative is really promising.
Yeah, well, I mean, we're seeing a lot of transformation with our customers on the science-based targets.
Yeah.
And although the first two scopes are relatively straightforward to monitor and to analyze, the Scope 3, as you said, it's really difficult, and in a lot of cases, pretty much all the cases actually, they're just estimating their carbon emissions through the products in use or what's happening in their supply chain. So we're actually, and through other initiatives such as the Digital Product Passport, we're trying to help our customers trace in using digital technology, of course, trace the use of the products to analyze their supply network in more detail, and to challenge, so they can challenge in turn their own supply network and get more information and bring it back.
Yeah, it's really vital to have that digital passports mindset and activity going forward, because one of your very first questions is, how do we make sure, do we actually have enough materials on the Earth crust that we can start mining? This is one of the ways to make sure that we keep a track and a trace and a responsibility of the materials we embed into our products, and also gives a direct motivation to keep the value add in the products. So from that material to component to product, to keep it in the product level. And if we can't do that, we can trace to see where the materials are and which components they're in, and how to keep them recirculated and how to stop waste. I think it's a really vital step forward for industry. And I think that I think within the next 5 years, I wouldn't imagine a company that wouldn't have some form of a materials passport activity with respect for itself. So I think it's the way.
So then in that case, I mean, how are you, if you could give us some ideas on how you're actually helping industry in that respect?
Yeah, so we have a lot of activities. So I'm a researcher, but as you can hear, I think my research is very close to industry. And as you also introduced me, my research object or my laboratory is companies. So I basically spend my time observing the activities and the needs of companies, and then from a science and a theory perspective, build methods and tools and have them tested out so that they can become available to allow these very bold goals to actually be actuated and put into action. So that's, in a nutshell, what my research is. We tend to call ourselves the tool makers in our part of the university here, making the methods and tools for ways to think, how do we design for disassembly? How do we design for circularity? How do we design for eco-efficiency? And importantly also, how to manage the trade-offs that always will arise between one or two or three of those different design for whatever's, design for disassembly versus design for low energy versus design for circularity. There could be lots of paradoxes and trade-offs there. And how do we design for those? So that's basically what I'm doing from a methods perspective. And then increasingly, what we're seeing is that the many insights that we get from the close contact we have through our research, through PhD projects and postdoc projects, but also larger research collaborations with industry and industry sectors, we see a need to raise the awareness of industry from a perspective of what is the problem, how to deal with it, but also to help industry to look inwards at themselves to see how ready are we to start to make a transition. Quite often, and I've been in this game for almost 30 years now in this research field, see really nice examples of companies doing one really great eco-design product or one really great circular product or one really great energy improvement in one factory, but can they do the second and the third and the fourth? Very rarely. And why so? Because they haven't embedded it into the way in which they develop and design their processes. They haven't understood what our current readiness is and where should we actually focus. So we may think that the circular business model is the way to go, but do we have the organization in place? And do we have a take-back system? Do we even know who the closest value chain partners are to work with? So to stop up at the beginning and say, how ready are we to get going? And then to help them to make what we call a transition path based upon that readiness. And then after that, once they are ready and they are starting to move, then we start to look at maturity. And then maturity is this exactly, how do we embed these processes so it doesn't just become the one product or the one project or the one factory, but we actually embed it into our processes again and again and again. So we spend a lot of time on that process. And you could almost call it a change management activity, but it's more than just change management because it's about deeply embedding the sustainability mindset into our readiness to change and then our maturity to really do the same and the right thing every single time. And I quite often, when I go to a new company who is maybe a little bit skeptical about this readiness and maturity approach, I would ask them, could you ever imagine not having a quality standard in your company? No, never. Could you imagine not having a safety procedure in place in your factory? Never, ever. Could you imagine not having ISO 9000, which is the quality standard if you're a production company? Never, ever. Our customers and our shareholders would never allow it. And then I ask, could you imagine not having a systematic way of thinking sustainability into your product development? Okay, now we get it. And that we get it is about the readiness and the maturity, about how do we look at the parallels from quality and safety and any other focus, you could say, that which has been embedded into industry thinking. How do we take that over into sustainability and make sure that we really understand how to embed sustainability into our activities? So even though there are some nice examples, and it's encouraging to see we're a long way off companies actually being really able to time and time again in a systematic way embed sustainability thinking into their product development processes, but also all the processes around the business development of the company.
Yeah, it's I think a big essential step to build in sustainability into companies, and right from the high level. And I think this is something as well that we can really understand, because this is the same sort of approach we have with digital strategy, because digital being an enabling technology. I just wanted to get your idea on your thoughts on what digital solutions such as product lifecycle management or computer-aided design, which is known old terminology now, or computer-aided manufacturing, digital twin, virtual twin. There's a lot of different names. How do you think these different digital solutions can help to transform companies from a high level, and also to bring some nut and bolt sort of solutions to people who are actually designing the products?
Yeah, I think there's of course a really important role for digital solutions at all different levels of an organization. If we start on, you could say, the operational level of companies, this is the way to see the can and the CAM, and they are old terms these days, and well established. And you guys are some of the world leaders in producing these solutions. And I think that from computer-aided design perspective, it's about helping designers to make the right decisions. So earlier I mentioned different design guidelines and design approaches about minimizing material consumption, low impact resources, optimizing product lifetime, and so forth. And different CAD solutions which exist today have different approaches to helping this. Some go very, very specifically at a materials level and help to make sure that we do a form of a life cycle screening up front as we're choosing a material over another. You could say, so is this material, if I choose this grade of metal versus this grade of metal, which is going to give me the biggest CO2 footprint? So that type of a solution is there and can be integrated, of course. But then also slightly more, less quantitative and more engineering design oriented decisions, such as what is an optimized product lifetime? What is how do I facilitate disassembly? How do I minimize material consumption? And in our research, we found over 800 methods and tools to support eco-design. And there's a fraction of those which are available in CAD and CAM systems today. There can be done more there to systematize, I think, what I call the design for X, design for recycling, no energy consumption and so forth, those tools there. If we stay at the operational level on the CAM perspective, then I think there's increasing opportunities for 3D manufacturing of parts, for if we're looking at keeping products in the useful life cycle for as long as possible. Automated disassembly, as in the example I gave with Apple before, that's an automated disassembly process, and there can be many different activities there. So basically looking at your car factory, which has a forward assembly system. If we next to it put a reverse assembly, a disassembly system, how do we automate that? And can they talk together, and can we mix and match parts? I think there's a great future there. If we lift it up from the operational to the tactical level, then I think looking at product life management systems, digital passports and so forth, super, super important. As mentioned before, I think that's the future for companies. And I put it at a tactical level because that's where you have the insight into the products, the product families, and where we have you could say, often the product ownership in companies. And then at the strategic level, how do we see ourselves as a company? What is our value proposition? Are we producing products? Are we actually delivering value? And if we're delivering value, so for example, if we go from being a car manufacturer to providing mobility, there's two different ways of thinking there. And providing mobility, you may still manufacture the car, but you may also provide all the different mobility solutions around there. And that digitalization has enormous ramifications and support possibilities there.
That's, well, of course, it's very nice to hear that. I'd like to add as well that what we're seeing is this need to intensify collaboration across so many more stakeholders than ever before.
Yeah,
and this, of course, is difficult to do just with regular communication sort of methods. And it also needs to be inbuilt again into the actual product design suite of tools, the platform that the people are using, so that we can break the silos. And there's something else I'd like to add as well, is that decision support. Today, life cycle assessment, for example, is today a topic which is generally dealt with at the end of the process, at the end of the chain, just by not generally with a couple of experts.
Yeah,
and then the experts will create a report. So there's a loop that has to be built in. It's not particularly very efficient. Designers and engineers can have access to this if they want, but it's not something which is built in. And this is something that we've been working on for a number of years, actually, at Dassault Systems. And we've built in a life cycle assessment suite of solutions, so that you can, as a designer and engineer, you're actually analyzing at any moment of your development phases the impact of your product on the environment.
Yeah.
So this is a way to accelerate bring these new products onto the market, which can replace the old ones in the fastest possible time.
Yeah, absolutely. I think it's really important to equip designers, product developers with ways in which to make informed decisions. Of course, it's important to remember that these ways of making the informed decisions are for internal use only, and it's to make internal benchmarks, but it helps you to make the right decisions up front. And then later on, when you do your full certified lifecycle assessment, then you can see, okay, this is the result of this piece of design work. And to match, I'd say, the decision support you just described with the improvements in the LCA, the full LCA performance, is really nice to see. And I've seen nice examples of how exactly supporting upfront in the design process through the digital tools is really informing designers and engineers to make their own decisions. And there's really an appetite out there for it. I don't meet any single company representative in my path anymore that is asking why we should do this, but they're asking what should we do and how do we do it and how can you help us? So I think the appetite for the tools at the right time, in the right level, is there. And I know that everyone wants simple tools, but if the simple tools were the ones which are necessary or known, then we would have solved this problem years ago. And the tricky thing is that these are complex problems we're sorting or dealing with here. And that's why we need some more complicated ways of helping us to make the decisions, which also talks to digital technologies.
Yeah, exactly. Thank you. More sophisticated, I'd like to say. So, Tim, well, thank you very much. I think we've had a very, very interesting conversation, lots of different topics. We could go on for another hour at least, I think. So any just closing remarks on your side, anything you'd like to add before we conclude?
I think that the main message I actually just gave it, I think, is that the appetite there is really large now in all different parts of industrial companies, in terms of understanding in a quantified way the life cycle, in tracking and tracing our products through digital passports, in understanding how to make the right solutions or the right decisions rather of materials choices, component choices are all really being sought after. One of the things I think we really need to keep focus on is to lift it from just the materials and the counting of the CO2 level, and also to include the more difficult decisions about the choices of, if we choose this route for the product, so let's say a refurbishment route at the end of its first usage life, versus if we choose another route which is about just disassembling, versus choosing a route where we're actually leasing the product and getting the value out of it from a completely different way. how does that affect our design, the design of our products, and therefore what possibilities will it give us? Because in my view, the higher we can lift the bar and the more we can value in the actual product produced after it's been produced, the higher chances we have for achieving what you asked me at the beginning, closing the mines and keeping materials in circulation if we keep them in the components and if we keep those components in the products for as long as possible. I think if the person watching this interview remembers nothing else, I think remember those 3 levels of products first, then components, and then materials at the end.
Great. Thank you very much, Tim. Excellent.
You're welcome.
Disruptors Unleashed is produced by Dassault Systèmes. For more episodes, follow us on Apple Podcasts, Spotify, Deezer, or your nearest audio streaming platform. To learn more about Dassault Systèmes, visit us at 3ds.com.